Hi fellas, this is Chemaddicts again to the solution. Well, today we are going to solve a problem related to ionic character. Okay, let's get started. Well, let's read the question first. Which of the following compounds has the greatest ionic character? Is it is it cesium fluoride, or is it iodide, cesium iodide, or is it potassium fluoride, or is it potassium iodide? Well, let's see. In order to answer this question, we need to find the keyword of this question. Well, the keyword of this question is the greatest ionic character. Okay. In order to answer this question, we first need to know which one should have the greatest which one should have the greatest ionic character. Okay. So the ionic character, at first we need to know what is ionic character. Ionic character is ionic character ionic character ionic character is the opposite of covalent character. Sorry for my bad handwriting. Ionic character is the opposite of covalent character. Okay, I hope that you have understood. Covalent character. I'm sorry again for my bad handwriting. Please forgive me for my bad handwriting. Okay, so ionic character is the opposite of covalent character. So the things that a compound should have in order to have greatest ionic character, the cations. Sorry, at first let us see which criteria ions should have in order to achieve greatest ionic character. Okay, the ionic character depends on size. It depends on size and charge of ions. Okay, ionic character depends on size and charge of ions, just like covalent character. Okay, size and charge of ions. So let's see, it depends on size and charge of ions. Okay, so we will deal here with size, not charge, because all charge are same here. If you have noticed, all charge are same here. Here cesium is +1, fluoride is -1, cesium here is also again +1, should be +1, and iodide is -1. Here potassium is once again is +1, and fluoride is once again is -1. +1 and -1. So you have seen that the charges are same. The cations have +1, each cations have +1 charge here in each option, and each anions have -1 charge in each option. So I hope that you have got that. Okay, so the charge is same here, so we are not concerned about the charge, we are just concerned about the size of ions. Okay, so constant charge is constant here, charge here it is constant. Okay, charge is constant here. Charge is constant here. Okay, so we will only concern about size, not charge. We will concern only about size. Okay, we will just concern about the size, not charge. So this is variable here, this is variable here, so size is variable, so we will just discuss about size here. Okay, so let's see, so which one should have the ionic character. So for cations, okay, for cations, let's see, for cations, large size large size will have strong ionic character. Okay, for cations, this is for cations. Excuse me, large size will have stronger ionic character. Okay, large size means stronger ionic character. So why? Because when the cations get larger, so let us see according to covalent character. So when the cations are larger, that means it can distort the anions any further, distort the electron cloud. So it is not it is not it is not able to distort or move, distort or move, same thing, distort the electron cloud electron cloud electron cloud away from anions. Okay, away from anions. Sorry, away from anions. So this will have minimum covalent character but maximum, this will result in minimum covalent character but maximum ionic character. Okay, so this will result this will result this will result this will result in minimum covalent character. So this would be minimum covalent character covalent minimum covalent character. Okay, covalent character but maximum ionic character. Okay, covalent character but maximum maximum ionic character. Okay, I hope that you have understood. Okay, so for stronger ionic character, cations should be large size. Cations should be in large size. For stronger ionic character, cations should be in large size. This will result in minimum covalent character but maximum ionic character. Okay, so let us move on to next one, that is for anions. Okay, for anions, okay, once again let us see, the charge is same. For anions the charge is same, so we will concern only about the size. Okay, size of anions. Okay, that means size smaller size will have larger ionic character or stronger ionic character. Size that is large large size will result in stronger ionic character. Okay, that is in the case of anions. Stronger ionic character. Okay, so why this will have stronger ionic character? Why? That is because of the size. Because if the anions are smaller, that will result the cations not able to distort the electron clouds. So anions are not distorted if the size is small. So the outer valence there will be a stronger attraction between the nucleus, this is nucleus, and outermost electron. There is a stronger attraction. Okay, so this will result in stronger ionic character. Okay, so the anions electron cloud won't be able to distort the electron cloud by the cations. Okay, so this is the cation and this is the anions. The anion is larger, this is plus, and this is the nucleus, and this is the valence electrons. Okay, so it won't be able to distort the electron cloud of anions. That's the point. Okay, I hope that you have understood. That is this would result this would result this would result in less covalent character. Okay, so why covalent character? Okay, so why this is happening? That's because of cations won't be able to distort the electron cloud of anions. Sorry, the electron cloud of anions. The electron cloud of anions. Okay, so this will result in low covalent character and very high ionic character. Okay, just like for cations that we have discussed before. Here this will result in minimum covalent character but maximum ionic character. Okay, for these reasons. So let's see which should be the answer. So let's look out for cations and anions. Okay, cations and anions. Excuse me. So let's look out for the size, which has the biggest size in the case of cations. Okay, which has the big cation. Okay, cation with big size. Okay, so is it cesium, potassium? Okay, cesium is in big size, since big cesium is lower. Cesium is situated in lower position in the periodic table, lower than potassium. If we look at the periodic table in group 1, we will see that cesium is below potassium, so cesium will have big size. Okay, cesium ions will have big size than potassium ion. Okay, so cesium ion should be the largest cation in this case. Okay, so we will look out for small size in the case of anion. Small size. Okay, in this case uh, fluoride is the smallest, since fluoride is at the top of the group 7 halide ions. As we have seen, fluoride is in the top of halogens, so fluoride will be the smallest. Okay, iodide will be the bigger one, since it is below fluorine in the periodic table. So fluoride ion will have small in size and iodide ion will be bigger. So fluoride is smallest. Okay, smallest cation. Sorry, fluoride ion is smallest anion. Fluoride ion is smallest cation. Anion. Fluoride ion is smallest anion. Fluoride ion is smallest anion. Okay. Fluoride ion. I hope that you have get the answer. You can guess the answer. I hope that you have guessed the answer. The answer should be A. Okay. So this is the end of today's tutorial. I hope that you have understood the question as well as the answer. Okay. So sorry for my bad English, and if you find any mistake in my in this video tutorial. If you find any mistake in this video tutorial, please forgive me for any kind of mistake, and forgive me, and especially forgive me for my bad English. Okay,